Hey Andrea, so this problem was about parametrics, and we know that the slope of parametrics is defined this way. And so that we know when the thing hits the ground at around this many seconds, the slope there will be y prime at that time divided by x prime, which was negative 0.987, and we were wondering why did they do inverse tangent of the positive value? It's a pretty clear explanation. Here we go. So we have our picture of the projectile hitting the ground and the tangent line there. We know the slope of the tangent line is the first derivative there, which is negative 0.987. It makes sense. This line has a negative slope. So consider that right triangle. If this is the angle we want, then we know from right triangle trig, tangent of this angle is equal to the opposite divided by the adjacent. So in the context of this right triangle and SOHCAHTOA right triangle trig, tangent of theta is b over a. But since sides of a triangle are positive, opposite over adjacent is a positive side length divided by positive side length. So tangent of this angle must be positive. And so while tangent of theta gives us the slope of this line, which is a line that goes down, has a negative slope, the actual rise and run is negative as a ratio. But in right triangle trig, tangent of theta is a positive side length divided by positive side length. So these have to be positive, and so we need to take the negative slope and make it positive in the context of this right triangle trig, which is what this equation came from. In other words, while the slope of the tangent line of this red curve is negative, the tangent of this angle is positive. And they're opposites of each other, so there it is. And now when we do inverse tangent, we get the angle theta, about 0.779 radians.